Really? This belch right when I get started? This is crazy. Alright. In this right triangle, we have a missing side. How do we find it? Starts with a P. Not even SOHCAHTOA. We don't have enough information. To be able to use SOHCAHTOA, we have to have an angle, and we don't.
Pythagorean.
Yeah, Pythagorean theorem. So, to do the Pythagorean theorem, what should we write?
What?
4 squared
plus b squared.
Yeah, so 4 squared plus, we want to call this side b, plus b squared equals 15 squared. And then I just say that's 11, right? 4 squared plus 11 squared is 15 squared.
Yeah.
Wrong. You can't do that.
What?
All right. So 4 squared. You guys were like, yeah, that's right. 4 squared is 16. All right. So we've got 16 plus b squared equals 225.
225.
So b squared equals 225 minus 16. 209. I believe you. All right, and then we square root it. So b equals the square root of 209. All right. Now, when we do ratios, it is not proper to have a decimal inside of a ratio. A ratio is just another word for fraction. And so when we do this, we have to call that side square root 209. We cannot use the decimal.
Oh.
Yeah. So these answers are not going to look very nice. Okay. Do you guys want to use theta first?
Yeah.
Actually, we're going to write this at the top of our paper just so you don't feel weird when you say it. This symbol right here, it's a circle with a line through it. And the way we pronounce it in English is we say theta. Theta is a Greek letter. This other one is like a capital B, but the line that you start with is just a little bit like extra long. That's beta. Do not turn this into a capital B. It's got to stay beta. We're going to use Greek letters. You got to get used to them because they happen a lot. The higher up you get in math, the more they start to use other letters from other alphabets to represent things. Okay. When you deal with trig, theta is a very common variable. You got to get comfortable with it. Okay. So, do we want to label our triangle based off theta first, or do we want to label it based off beta first? We'll do theta. All right. So the right angle always points to the hypotenuse. That's the only side whose name never changes. That is forever the hypotenuse.
In both these problems, the examples we said, the first sentence said we didn't have to do a hypotenuse. What would you do with that?
I don't know. Since it's always the same, I guess. All right, we're starting with theta. So which side is opposite of theta? 4. So this is opposite. Opposite means across from. All right, and then square root 209 would be what side then? Adjacent. What does adjacent mean? It means next to. Yeah, so this is the side that is next to the angle. All right, so sine. Let me cover this up because it's messing with my brain. All right, sine, so, is opposite over hypotenuse. So what should I write? 4 over 15. Cos is ka. That's adjacent over hypotenuse. So what should I write? Root 2 over 9. Sorry, root 209. Sorry, over 15. Good. And then toa is tan. Yep, 4 over square root 209. Okay. And then what do we do to find the other 3? Yeah, we flip. Okay? So cosecant is the flipped version of sine, so that's going to be 15 over 4.
15 over square root 209.
And then cos is, or secant is the flipped version of cos, so 15 over square root 209. And then cotangent is the flipped version of tangent, so square root 209 over 4. Alright. Then to do beta, we have to erase adjacent and opposite. We have to erase those labels because those labels are dependent on the angle that you're talking about. So now if we're talking about this angle right here, then which side is opposite? The question mark. So square root 209 is opposite. And then which side is adjacent? 4. Alright, so sine would be so.
Okay.
Yep. So opposite over hypotenuse. Let's put any crinkly things just away until I finish the video because there's just an awful lot of food happening right now. Alright. Cos is ka. 4 over 15. And then tan is toa. So square root 209 over 4. And then what do we do for the other 3? Flip, flip, flip. So cosecant, we're going to flip sine. 15 over square root 209. For secant, we're going to flip cos. So 15 over 4. And then for tan, we're going to flip, or sorry, cotangent, we're going to flip tan. So that's 4 over square root 209.
Don't tell me what to do.
So now we're going to go ahead and we're going to look at some triangles that are drawn on a coordinate axis because, are you guys listening? Sometimes when we do math, if we take a triangle and we put it on a coordinate axis, we can have a side length of a triangle that's negative. Have you ever had a side length of a shape be negative before?
No.
No. But now that we're dealing with trig, we can start to draw shapes inside the x and the y plane, and that means that sometimes we're going to go left. And so that side length is going to be considered negative because we went left to do it. So we're going to go ahead and we're going to look at number 3. We're going to do number 3 together. The instructions tell you to draw a right triangle from the point. So the first thing we're going to do is we're going to draw the point 6, negative 4. So we're going to go to the right, 1, 2, 3, 4, 5, 6, down, 1, 2, 3, 4. And here's how I want you to draw the triangle. You're going to draw a line straight to the x-axis. So from the point, draw a line straight to the x-axis. And then from the point, you're going to draw a line straight to the origin. So here is your triangle. We are going to label theta as the angle that is at the center. So right at the origin, that's where our theta is. So there's theta. So this side length right here.
Why can't I draw it like this?
Because we always draw them the same way. Sorry. It'll make the further on you get in math, the more you'll start to realize, like, oh yeah, they really do always draw it like that. Okay. So this side length is 6 because I counted 6 before I drew my point. And this side length we're actually going to call negative 4. Alright. So how do we find that missing side length? Pythagorean theorem, right? So we're going to say 6 squared plus negative 4 squared. Now, if you do not put parentheses around negative 4 and you type it in your calculator, you're going to get it wrong. So make sure you put the negative inside parentheses with the 4. So 6 squared plus negative 4 squared equals c squared, right? Or hypotenuse squared. You could use h if you wanted. So this is 36 plus 16 equals c squared. 52?
Yes.
52 equals c squared. So what is our c value? Square root 52. Okay. Now, the other part of the instructions ask us to find sine, cosine, tangent, cosecant, secant, and cotangent of the angle. They want us to find all 6. Okay, so this time we don't have a theta and a beta, we only have a theta. Okay, so we're just going to label the triangle once. So which side is the hypotenuse? Square root 52. Here's our hypotenuse. Okay. If theta is right here, which side is the opposite? Negative 4 is opposite. And then which side is adjacent? 6. So there's our adjacent. Okay. So now we can go ahead and we're going to find sine of theta, cosine of theta, tan of theta, cosecant of theta, secant of theta, cotangent of theta. One of the things that I am particular about is if you just write sine equals. If you don't put the theta there, I will mark off points. Okay, here's the reason why. If you have a calculator near you, press the sine button. What does it do? It pops up parentheses. It's automatically saying sine of what? There's no such thing as sine. It's sine of an angle. Does that make sense? It's kind of like if you were telling me 6 plus on your paper. And I'm like, okay, 6 plus what? What are you adding to 6 to give an answer? If you just write sine, that doesn't make sense. It's like a sentence you started but didn't finish. Okay? So sine of theta, I got to see the theta there. All right. So sine, we got SOHCAHTOA. So what should sine be? Yep, negative 4 over square root 52. All right, what should cos be? 6 over square root 52. What should tan be? Yeah, negative 4 over 6. And what can we do with negative 4 over 6? Yeah, what can we call that?
Oh, 2/3.
Negative 2/3. So I'm going to cross that out. I'm going to put negative 2/3 instead. So if you can reduce your fraction, you should reduce your fraction. Okay. Now, how do I get the other 3? Flip, flip, flip. So cosecant is root 52 over negative 4. Secant is root 52 over 6. Cotangent is 3 over negative 2. Okay, so if you flip to this page right here, all right, so here, this is where we're going to be finding the missing angles and the missing sides. And the first thing that I like to do is I like to label my triangle with the names of the sides. So here's the angle that we were talking about. So what labels can we put on the 2 sides that they gave us? So yeah, so the right angle points to the hypotenuse, so this is the hypotenuse. Yeah, this is adjacent. The side they didn't give us was opposite, so that's not very helpful for us. So which trig ratio uses adjacent and hypotenuse? Cosine, right? SOHCAHTOA, it's the ca part. So we're going to say cos of the angle, so cos of 53 equals adjacent over hypotenuse. So x over 12.5. And then how do we solve for x? Yeah, you can actually get away with not cross multiplying on this one if you want to. You could just multiply the 12.5 to the other side. That would work.
But it's not 12.5 over x, then you put the 53.
If it was 12.5 over x, then we would be putting it over 1 and cross multiplying for sure. But here we can just multiply the 12.5 to the other side. So we're going to say that that's going to go away and we're going to put it over here. So 12.5 multiplied by cos 53 equals x. And this right here is the exact answer because we've gotten the x all alone. Now we need to go ahead and type this in our calculators. And to type this in, you have to first change your calculator into degree mode. And our calculators by default are in radian mode. So what we do is we hit the mode button. So everyone on your calculator hit mode. And if you can see, it's dark on radians. We got to go switch it to degrees. And you're going to have to do that pretty much every time you grab a calculator to work with. Right? When we deal with triangles, all of our answers should be in degrees. The only time it matters what your calculator is in is if you hit one of those three buttons. If you hit the sine button, the cos button, or the tan button, then it matters. If you're not going to use those three buttons, the mode does not matter. Did we hear that? The only time the mode matters is if you use those three buttons. If you're not going to use them, it doesn't matter. All right, now I'm going to hit second quit to get out of that. I want to type into my calculator 12.5 cos 53.
7.5. Round to the nearest tenth.
Round to the nearest tenth, so that's one decimal place. So we're going to say 7.5. And what are the units? Miles, yeah, MI, miles.
Rotating.
All right, let's go ahead and do number 2. So here's the angle that we're talking about. And what labels should we put on the sides?
Height.
Yeah, hypotenuse is the x, right? We point to the hypotenuse with the right angle. And then what's this one? Opposite.
Are we looking for tan?
So which one uses opposite and hypotenuse?
Oh, sin.
Sine. Mhm.
Sine.
Yeah, you're good. So we're going to say sine of 41 degrees equals opposite over hypotenuse. What should I be writing?
4.3 over x.
Over x. Now this problem is a little bit more difficult than the one we just did because our variable is trapped on the bottom right now. So anytime you have a variable trapped on the bottom, we're going to take this one, we're going to put it over 1, and we're going to cross multiply. So if you cross multiply, what do you get?
176.3. No.
4.3 equals x sine 4.
Yeah, x sine 41, right? And then how do we get the x alone? Divide by sine 41. That was like a math religious joke. Also, do we know that that's like you have officially reached math nerddom when you are cracking math jokes in class? When you're thinking of them yourself.
Get out of here.
So 4.3 divided by sine of 41. So 6 point, if we do one decimal place, what should we put? 6. 6.6, what are the units? Centimeters.
Okay.
All right. All right. So we're going to do the same thing. We're going to do the same thing we did last time. We're going to write down what angle we're looking at. And then we're going to label the sides. So what names should those sides have? Adjacent, which one's adjacent? 16. So this is adjacent. What's the other one? Opposite. Opposite. So which trig function are we using? Tan. So we're going to say tan of the angle. What's the angle? Theta. It's theta. Good. Equals what? You can't say 0 because it's not 0.
6.4 over 16.
And theta is our variable that we're solving for, so we have to get rid of tan. How do you get rid of tan? You don't divide.
Multiply.
You don't
Subtract.
Yeah, tan with the little negative 1, it's called tan inverse. Tan inverse the left side, and if we tan inverse the left side, what should we do to the right side?
Nothing.
Tan inverse, same thing. So the tan inverse and the tan are they're inverses of each other. They undo each other. So we have theta equals tan inverse of 6.4 over 16. There's our exact answer. How do we get tan inverse up on our screen?
Second tan.
Second tan. 6.4 over 16.
Third tan.
Not third tan. Oh my
Don't
goodness.
say
All right. 21.8. What are the units?
Mine.
Degrees. We're finding an angle. The units are degrees.
But it's 60.
Like uno. Uno.
All right. Let's try number 13. Let's make sure the answer is right. So here's our angle. What are the two sides called? Opposite and hypotenuse. So which trig function are we using? Sine, yeah. Yeah, opposite over hypotenuse would be sine. So sine theta equals
14.
okay. And how do we undo sine?
Inverse.
Sine inverse. So sine inverse the left side, sine inverse the right side, and those cancel. So theta equals sine inverse of 14 over 15.
This is 69.
Oh, so they did not get it right. We got to fix that answer.
Is it right?
Wait, 68 point, the 9 is followed by a 6.
This is 69.
Yeah, it's 69.0. Right, we got to put the point 0 because we're still doing it to the 10.
Okay.